So revisiting the first example that we did yesterday, here's my system of equations. It says that x plus y equals 8, 2x minus 3y equals negative 9. And if you remember when we did it by hand, we worked from left to right. So I eliminated x and I said, okay, here is first equation, here's the second equation. And then how was I going to do? I was going to eliminate x. And I'm going to do that by taking negative 2, multiplying it times the first equation and adding it to the second equation. So I'm going to take negative 2 and multiply it times equation 1, which is going to be negative 2x, negative 2y equals negative 16. I'm going to add it to the second equation, which is going to be 2x minus 3y equals negative 9. The x's drop out. That gives me negative 5y equals negative 25. And then y is going to be positive 5. Then we went in and found x. So if I know that y is 5, I know that x plus y equals 8. So that x plus 5 equals 8, or x equals 3. So my answer was x equal 3, y equal 5.
When I'm writing my answer, do you want it like that, or do you want it in like...
Sometimes I'll ask you, and I think on the one on the exam, I'll ask you to write as a coordinate point.
Yeah.
And then I know for my intermediate algebras, I usually put x equal, y equal, and then they fill in the blank x equal, y equal. So it depends upon what you're doing with. If you're doing it with an application, there's going to be specific questions you're going to answer because it's an application problem. Depends upon what you're going to do with it. But I know the one that I'm asking you to work by hand, I ask you to write it as a coordinate point, namely x, y, and z. So here we go. The first thing that I'm going to do, we're going to do this problem using matrix row operations. So now we're going to talk about the process. And the augmented matrix for this system, I'm going to have 1x, 1y, 8, 2x, negative 3y, and negative 9. Now our goal is to put this in upper triangular form. And if you remember, what I'm going to do is go down the main diagonal, and everything below the main diagonal, namely only that position right there, is going to need to be a 0. I'm going to use this 1 to create that. So using the notation from yesterday, this is row 1, this is row 2. I'm going to use row 1 to get rid of that 2 in row 2. And how am I going to do that? I am going to take negative 2, multiply it times the old row 1, add it to the old row 2 to give me a new row 2 that's going to have a 0 in that position. Now what we're doing is essentially, whenever we went through the notation, just the notation of those first things we did row operations on. So this says I'm going to take negative 2 times row 1, which is going to be negative 2, negative 2, negative 8. I'm going to add it to the old row 2, and I'm going to have a matrix with a new row 2 in it. So that this is 2, negative 3, negative...
Yeah, I was going to ask you, do we do it with the...
I forgot the 2 on this guy, which is negative 16, negative 9. So this is 0, negative 5, negative 15. So my new matrix looks like this. 1, 1, 8, 0, negative 5, negative 25. And now, if I look, it's in upper triangular form. Everything below the main diagonal is 0. So I'm now going to rewrite it as a system. X plus y equals 8, negative 5y equals negative 25. I can now solve for y. Y equals 5. And then I'm going to, what we call, back substitute. To find x. So that x plus y equals 8, x equals 3. Now there is a direct relationship between that matrix and what we do by hand. And if I follow the process down, I go back up here, and here are the two side by side. And I said I wanted to eliminate x, so I multiplied the first equation by negative 2 and added it to the second equation. That's the same thing as taking negative 2 times row 1, adding it to row 2 to give you a new row 2. And what did I end up with? I ended up with this guy, which is essentially that row in that matrix. And then, once I get it down to upper triangular form, that means everything below the main diagonal is 0, everything above the main diagonal doesn't matter, is that I rewrite the system and then I solve for x and y. And essentially, I'm now back to this guy right here. Now, for systems of equations, which are 2 equations and 2 unknowns, I rarely use matrices to solve them because it's a heck of a lot easier. There are other methods. And certainly this one is just as easy to solve by hand without going into matrices as it is to solve by matrices. In fact, it may be a little bit more complicated to use matrices on it. But when I get into the bigger systems, and that's what's going to happen is very few real-world applications that I think about what's going to happen in the sciences, whether you're looking at physics or whether you're looking at chemistry, where you might use this stuff, is going to only have 2 variables. Most of them, and I can remember in physics, it wasn't unusual for me to have 5 variables. And then we use something ugly something that I don't do anymore, but something called Cramer's rule. We don't have to do that if you're actually solving. You can then use your calculator to do that.